In this video, we will practice solving basic trigonometric inequalities. This is AP Precalculus topic 3.10. If you appreciate the content, please give it a like. Number 1. What are all values of theta on the interval from 0 to 2 pi for which sine theta is less than negative 1/2? In order to find where sine theta is less than negative 1/2, we first must find where sine theta is equal to negative 1/2. We can find the reference angle by asking the sine of what is 1/2, ignoring the negative sign. We have memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. A reference angle is the angle between the terminal side and the x-axis. On the interval from 0 to 2 pi, here are the four angles with a reference angle of pi over 6. Since we want sine to equal negative 1/2, we will focus only on the third quadrant and the fourth quadrant, where the y value, and thus the sine function, is negative. We can think of pi as 6 pi over 6. Therefore, this angle in the third quadrant is 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. The sine function gives the y value, or vertical displacement, on the unit circle. So we just found that the sine of these two angles is negative 1/2. In other words, at the end of these two angles, at the intersection point, the vertical displacement, the y value, is exactly negative 1/2. I'm representing the y value of negative 1/2 as this light blue line. We are looking for where the vertical displacement is less than negative 1/2. So we are looking for where the end point of a rotating segment like this one falls below the light blue line. Because our domain begins at 0 and ends at 2 pi, we need to start our rotation at 0 and we need to end our rotation at 2 pi. So, starting from 0, notice that the vertical displacement is above the negative blue line. So this will not be a solution yet. Focus on that endpoint. As I rotate around, the y value stays above the light blue line. The vertical displacement is greater than negative 1/2 until I get to this position where the vertical displacement is exactly negative 1/2. This will still not count as a solution because we want to know where the y value is less than negative 1/2. That begins as I pass 7 pi over 6. So we are now into the solution interval. For all of the angles between 7 pi over 6 and 11 pi over 6, notice that the y value, the vertical displacement, is below negative 1/2. 11 pi over 6 will not be a solution, again because the vertical displacement is equal to negative 1/2 here, and we want only where the vertical displacement is below negative 1/2. So the solutions will be between 7 pi over 6 and 11 pi over 6, not including those endpoints. As I pass 11 pi over 6, we have no more solutions as the y value is above negative 1/2. We can write the solution in interval notation like this. We use parentheses to show that the endpoints 7 pi over 6 and 11 pi over 6 are not included in the solution set. Or you could record your answer as an inequality. In this case, we use less than signs to show that the endpoints are not included. If the endpoints were to be included, we would have less than or equal to. Number 2, what are all values of theta between 0 and 2 pi for which cosine theta is greater than or equal to negative radical 2 over 2. To find where cosine theta is greater than or equal to negative radical 2 over 2, we begin by finding where cosine theta is equal to negative radical 2 over 2. We can find the reference angle by ignoring the negative sign and asking the cosine of what angle is radical 2 over 2. We have memorized that the cosine of pi over 4 is radical 2 over 2, so pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the four angles with a reference angle of pi over 4. Since we want cosine to equal negative radical 2 over 2, we will restrict ourselves to quadrants 2 and 3, where the x value, and thus the cosine, is negative. We can think of pi as 4 pi over 4. So this angle in the second quadrant is 3 pi over 4, and this angle in the third quadrant is 5 pi over 4. Cosine gives the x value, or horizontal displacement, on the unit circle. The cosine of both of these angles is negative radical 2 over 2. So at these two intersection points, the horizontal displacement, the x value, is negative radical 2 over 2. So I am indicating a horizontal displacement of negative radical 2 over 2 using this vertical light blue line. We are looking for where the horizontal displacement is greater than or equal to negative radical 2 over 2. In other words, we are looking for the angles where the endpoint is to the right of this blue line. Since our domain restriction goes from 0 to 2 pi, we must begin our rotation at 0 and rotate until we get to 2 pi. So right here at the start, is the horizontal displacement greater than or equal to negative radical 2 over 2? Well, yes, the x value of this endpoint is to the right of the light blue line. So solutions begin immediately at 0, including 0 itself. The horizontal displacement continues to be greater than negative radical 2 over 2, all the way until I get to 3 pi over 4. 3 pi over 4 is still a solution because at 3 pi over 4, the horizontal displacement is equal to negative radical 2 over 2. We do want to know where cosine is greater than or equal to negative radical 2 over 2. So that is one set of solutions, from 0 to 3 pi over 4, including 0 and 3 pi over 4. Here is our first set of solutions in interval notation, and here it is written as an inequality. Let's pick up where we left off. So we found solutions from 0 to 3 pi over 4. However, as we pass 3 pi over 4 in our rotation, we no longer have solutions in this interval because the horizontal displacement, the endpoint, is to the left of negative radical 2 over 2. The x values are to the left of this light blue line. So we will have no solutions between 3 pi over 4 and 5 pi over 4. However, as we pass 5 pi over 4, the solutions begin again, because actually the solutions begin at 5 pi over 4, where the horizontal displacement is again equal to negative radical 2 over 2, which is one of the things we are looking for, greater than or equal to. And we will continue to have solutions for the rest of the rotation from 5 pi over 4 all the way until 2 pi, including 2 pi itself. Actually, 2 pi cannot be included in the solution set because 2 pi is not included in the domain. Notice that we have the less than or equal to sign next to the 0, but next to the 2 pi we just have a less than sign, showing that 2 pi is not included in the domain. So we will show that 2 pi is not included by using a parenthesis in interval notation and a less than sign without the or equal to in the inequality. But overall, this is your full solution to number 2. Number 3, let f of x equal sine x. What are all values of x in the xy plane on the interval from 0 to 2 pi for which f of x is less than or equal to 0? Notice that 2 pi is included in the domain this time. See the or equal to sign. We begin by finding where f of x is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 right at the beginning of the rotation at 0 radians, and then again right here at pi radians. This purple line now represents a vertical displacement or a y value of 0. We are looking for all angles between 0 and 2 pi where the vertical displacement is less than or equal to 0. So on the line or below the line. Because the domain goes from 0 to 2 pi, we start at 0. Obviously, right at 0, we do have a solution because we are looking for where the vertical displacement is equal to or below 0. So right here we are equal to 0. So we're going to begin with a solution. However, as soon as we begin to rotate, we no longer have a solution. So we had a single solution and then nothing because now the vertical displacement is above the purple line. So this is not a solution. We only want below. So we have one solution and then no solutions as I continue to rotate all the way until I get to pi. And then I hit another solution. And then after that, we are back to having solutions again because the vertical displacement, the y value, look at this endpoint, is below the line, below 0, between pi and 2 pi. So, here is the solution in interval notation. To review, we started with a single solution at 0 because the vertical displacement is equal to 0 at 0 radians, no rotation. And then we had no solutions for a while, so I had to say union, and then the solutions picked up again from pi to 2 pi. I should put a 2 pi here. From pi to 2 pi, we did have solutions, including the endpoints, including pi and including 2 pi. So we will use brackets. Here's the solution in interval notation, and here's the same solution written using inequalities. Number 4, let f of x equal 3 minus 4 cosine x, and let g of x equal 1. What are all values of x in the xy plane between 0 and 2 pi, for which f of x is less than g of x? So we are looking for where 3 minus 4 cosine x is less than 1. Let's simplify this inequality by getting cosine x by itself, subtracting 3 from both sides. We have negative 4 cosine x is less than negative 2. Please be very careful right now. When you multiply or divide both sides of an inequality by a negative number, you have to remember to reverse the direction of the inequality. So we need to divide both sides by negative 4, but this will give us cosine x is greater than 1/2. We actually begin by asking ourselves where cosine x is equal to 1/2. We can find the reference angle very easily because we know that the cosine of pi over 3 is 1/2. So pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we want cosine to equal positive 1/2, we will stick to quadrants 1 and 4, where the x value, and thus the cosine, is positive. The angle in the first quadrant, with a reference angle of pi over 3, is pi over 3 itself. We can think of 2 pi as 6 pi over 3. So this angle in the fourth quadrant is 5 pi over 3. The cosine function gives the horizontal displacement on the unit circle. So the cosine of both of these angles equals positive 1/2. Therefore, the horizontal displacement at these two endpoints is 1/2. So this light blue vertical line represents a horizontal displacement of exactly 1/2. We are looking for the angles where the horizontal displacement is greater than 1/2. So we are looking for the angles where the horizontal displacement is to the right of this light blue line. The domain goes from 0 to 2 pi, including the endpoints 0 and 2 pi. So we have to begin our rotation at 0 and end at 2 pi. So beginning the rotation at 0, we ask ourselves, is this a solution? We want the horizontal displacement to be greater than 1/2. We are further to the right than 1/2, so 0 is a solution. And we continue to have solutions. We continue to be to the right of the blue line as we rotate until we get to pi over 3. Pi over 3 will not be included as a solution because we only want greater than 1/2, not equal to 1/2. So to review, our first set of solutions goes from 0 to pi over 3, including 0, but not including pi over 3. We show that 0 is included with a bracket, and we show that pi over 3 is not included by using a parenthesis in interval notation. So let's pick up where we left off. So here we are at pi over 3, which is not a solution. As we continue to rotate, we no longer have solutions because the horizontal displacement is now less than 1/2. We are to the left of the blue line. So we will have no solutions from pi over 3 all the way around to 5 pi over 3. At 5 pi over 3, this is still not a solution because this is where the horizontal displacement is exactly 1/2, and we want only greater than 1/2. So 5 pi over 3 is not going to be a solution, but after we pass 5 pi over 3, we have more solutions because this endpoint is to the right of the blue line. The horizontal displacement is greater than 1/2. And that's going to be between 5 pi over 3 and 2 pi. What about the endpoint of 2 pi, which is in the domain, so we have to consider it. At 2 pi, the horizontal displacement is greater than 1/2. So 2 pi should be included. So I'm about to record solutions between 5 pi over 3 and 2 pi, not including 5 pi over 3, but including 2 pi. Here's your solution set in interval notation, and here it is again written as an inequality. Number 5, let h of x equal 2 sine x, and let k of x equal 1 plus 4 sine x. What are all values of x in the xy plane between 0 and 2 pi, for which h of x is less than or equal to k of x? So here's h of x less than or equal to k of x. We can simplify by subtracting 4 sine x from both sides. That's going to give negative 2 sine x is less than or equal to 1. Be careful once again. We are about to divide both sides of this inequality by a negative sign. And as we do so, we must remember to reverse the direction of this inequality. So we will now have sine x is greater than or equal to negative 1/2. We actually begin by finding where sine x is equal to negative 1/2. And we will find the reference angle by ignoring the negative sign and asking the sine of what angle is 1/2. We have memorized that the sine of pi over 6 is 1/2. So pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine x to equal negative 1/2, we will stick to quadrants 3 and 4, where the y value and thus the sine function is negative. We can think of pi as 6 pi over 6. So this angle in the third quadrant is 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. The sine of both of these angles is negative 1/2, and sine represents the vertical displacement or the y value on the unit circle. Therefore, this horizontal blue line represents a vertical displacement, a y value, of negative 1/2. We are looking for where the vertical displacement is greater than or equal to negative 1/2. So we are looking for the angles where the y value will be above this blue line. Since the domain goes from 0 to 2 pi, including 0 and 2 pi, we have to start our rotation at 0 and then end at 2 pi. So starting at 0, ask yourself whether this is a solution to the inequality. We want the vertical displacement to be greater than or equal to negative 1/2. The endpoint here is above the blue line, so this is a solution. So we start right off with a solution at 0. As we rotate, notice that this endpoint continues to be above the blue line. The vertical displacement, the y value, is above negative 1/2 the entire time from 0 until 7 pi over 6. At 7 pi over 6, the vertical displacement is exactly negative 1/2. We are touching the blue line. Is this also a solution? Yes, it is, because we want sine x to be greater than or equal to negative 1/2. So right here at 7 pi over 6, the horizontal displacement is equal to negative 1/2, so that's to be included. So we have our first set of solutions from 0 all the way to 7 pi over 6, including the endpoints. Let us pick up where we left off. After 7 pi over 6, we no longer have solutions because the vertical displacement, the y value, is now below negative 1/2. We are below the horizontal line. So we will have no solutions between 7 pi over 6 and 11 pi over 6. Solutions begin again right at 11 pi over 6, where the vertical displacement is exactly negative 1/2. So 11 pi over 6 is a solution, and we will continue to have solutions between 11 pi over 6 and 2 pi, including 2 pi. So from 11 pi over 6 to 2 pi, the vertical displacement, or the y value, is above negative 1/2. So these will be the remaining solutions. Here is the solution in interval notation, and here's the solution written as an inequality. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.